Oh, hello. I mainly waited for this bot right here. Good evening. Good evening, guys. It is Friday, Saturday night. That means we get to do something fun. Hello. Hello. I guess I should say hello to everyone who's here already. So, hello, Sugar. Hello, Tyler. Hello, me. Hello, Nep. Hi, Nep. Oh, she went to cook something. Hi, 𝖘𝖈𝖎𝖆𝖎𝖙𝖘. Hi, Tyler again. 𝖘𝖈𝖎𝖆𝖎𝖙𝖘. How's it going? Let's see. Yeah, who has the brain cell right now? Did you leave it somewhere? Also, let me adjust my volume. I know I am loud, and I can actually get closer to the microphone for crisper audio scenarios. Yeah, that's what I'm supposed to use. I noticed my mic quality the other night wasn't too hot, just because I am just a bit low, a little bit quiet. Music's too loud. Oh, man, I was loving it. I was just jamming out. I'm sorry. I got lots of jams. Finally, some different music, I'll tell you that. But yeah, how's everyone doing tonight? How's it going? Did you do anything fun? Sounds great. Sounds great. Nice. We want that. We want that. I had a good day. I worked, and the drive wasn't as awful as that. Actually, the morning was pretty bad. And then today I covered some lessons with my students, and one of the things I ended up doing was kind of re-explaining. I taught one of my students the idea, or at least they were willing to hear the pitch, about my square root method. The square roots. You can do square roots by hand, and I love that thing so much. I actually think it's the most fascinating thing in the world. It's fun. It's fun. Yeah. You're lesson prepping for tomorrow? What kind of lesson? What subject? Tell us, please. What is fun? That's what we want, right? I don't know what is fun. I've been doing nothing but math. But only because I genuinely just enjoy it. I don't mind prepping like lessons and stuff like that, but that's just doing things live is honestly just so fun. Just being like, hey guys, did you know you could go oh my gosh, and it's like amazing-ish, you know? Maths, grades 7 to 9-ish, weekend enrichment tutor school. Ooh, at that level, what are they doing? I might suspect, like late stage algebra, early geometry. Or are they doing like trigonometry at that level? It's also my weekend. My weekend finally has started, so I get to relax. I want to relax. So today's gonna be a bit more of a chill stream, but like with some fun wackiness, okay? I'm very much inclined to have a good time. Level 1 angles class, level 2 class of different number bases. Ooh, they're gonna learn about binary systems, hexadecimals. So multiplying in base 4? Ooh, actually, do I? On a whim? No, I don't think I know how to do that. Well, no, yeah, of course. I mean, I know what that is. Yeah, of course. You told them 0x dead beef. What is that color? Is that a color? Ready to learn? Thank you, Sugar. Sugar Oni. I think I'm ever saying that. Okay, you're gonna be called Oni because Sugar just sounds like interesting. Hexadecimal error code. Is that the error code? Really? Yes, you can learn, Tyler. So, I want to cover some stuff again. I want to pitch again the square root stuff. I think I have a better delivery on how to do it in like about 30 minutes. We don't have to do too much time, but 30 minutes is just about my time limit for it. Then following that, what I want to do is I want to break into some of the Fractal stuff I just did. So, if you guys were in the Discord, you also saw a video that I had just recently made from the other day. What I did is I rendered it out, and that was in the ray tracing engine. It does not look very good at all in the game engine, if that makes sense. So real time feedback on animation stuff is actually gonna be hard because my computer is a bit slower. So ray tracing and stuff, that's why I haven't been able to play any wacky games, because my system just can't run it. I might have that as a reward if anybody's willing to buy me a graphics card, but I mean, or at least contribute to the goal of it. And that's really all I need for like the next big while. So, what is that? Throne or something? I guess I can open up Throne. But I'm gonna look into things in the future. But in the meantime, I ended up the stream ended up crashing. I ended up having a raid, which was really cool, by Suzu. It was really cool, but I felt so bad because like literally the internet just crashed, so I was bummed. But one of the cool things that came out of it was me still working on this. So I want to show you guys the video that I made that night. So this is in my renders real quick. I think it was MP4 or the MOV, either way. So it is gonna be, I'm gonna lower my volume here for a second, and then we're gonna go over to the my media page right here. I'm also gonna bring up the volume on this. So yeah, did anyone happen to see it recently? I'm pulling it up right now, so don't worry. Okay, I'm just gonna show it then. Yeah, it's running at a full 60 frames per second. It's so cool. Actually, wait, this doesn't have the sound, it doesn't have the audio to it either. Yeah, no, this was really cool. Pretty trippy, huh? I guess it's this one isn't the one with the sound edited into it. But if you wanted the original, then it's on the online. It looks good. It's 60 frames per second. My only issue is that the camera angles are a little wacky. So cool. I uploaded it the other night, and yeah, it just got about 2,000 views on its first viewing. And then the life cycle ended, because that's just how shorts work. So yeah, that was really cool. But I do know I could mix this a little better. And I do know the process to make it work. What I was struggling with last time, for those inclined to know, I'm gonna keep it on the side over here. Hold up. I'm gonna keep it on the side over here real quick, and then move myself over. So my issue from last time was that it's a video with all the shapes that you see on screen. Those are all additive. What I was trying to do initially was subtractive modeling, and subtracting, especially Boolean meshes, is actually a pain in the butt. It is incredibly difficult to do, especially computationally. Think of it like this: is it easier to multiply numbers together or easier to divide? So if I asked you guys, what's 2,000 times 3,000, or I guess 25 plus times 25. It's easier to multiply than it is to divide, right? So, and it works the same with meshes, because the mesh data is actually getting scuffed, right? So that's what happened here. It was that the mesh data just kept, because it was also an input for the next iteration, it was not good. So you have to kind of make these things iterative in the addition way, not necessarily the subtractive way, which unfortunately is a bummer, but it makes a lot of sense, because honestly, you can't just break things apart the way you want to. You learn division after multiplying using multiplication. Yeah, that's the whole point. You want to work with your multiplication table, and if you think about it, let me actually show this off a bit too. Not that. let's move over to the... Let me see what my current screen is showing right now. I don't want to see that. I want to do that. Where we can follow up with our notes, okay? So let's move on over really quickly to some notes. Yeah. So for all of you guys, keep the audio back. All of you guys who maybe took a programming course before, these are some notes I did last time. So I'm gonna do a new layer and hide this one. Let's think about what operations we do. Okay. If I want to do multiplication, give me two numbers to multiply real quick. Um, 6 and 7. Brilliant. Sure. I'll go ahead and do that. Actually, I need two digits. So I need 2 digits. $69 and $420. Honestly, that works too. Yeah, let me go ahead and do that. Okay. Let's think about all the numbers we're working with, okay? 67, 69. We'll do that next time, okay? So, let's look at 69 times 420. Okay? So, let's count how many operations of multiplication we actually do. Okay? So, I'm going to have a big old counter right here on the side called multiplication. Okay? The brain rot's good. What are you talking about? I let that pass. Okay, so we're gonna do the things. We're gonna count our multiplication, and then we're gonna count our addition. Okay. So, 0 times 9. What is that gonna be? Right. 0 times 9 is gonna be what? 0. Duh. So that's how many? I'm gonna do a tally. How many multiplications was that so far? 1. Doing a little tally right there. Okay. Oh, hold up. Give me a second. Sorry about that. Car parking issues. Nothing to worry about. Okay, that was 1 multiplication, right? Okay. 0 times 6. How many? What is the answer there? Gaussian, you got to do the dollar signs. If you want money, you're gonna have to use the dollar signs. Okay, everyone, guys, look, it's Gaussian. It's Gaussian surface. Gauss, you have your own command. You have your own command. Do you want to use it? Do you want to see what it is? Do you want to use it? You want to see what it is? Do you want to see what it is? You want to see it? You want to do it? Guys, type exclamation point Gauss in the chat, and Gauss must see it. It's gonna pop up on my side right here. Okay, Gauss is gonna do it. Oh, I think it's on cooldown, so don't worry about that. Look at that, Gauss. Look at that, Gauss. It's you. It's you. It's the Gaussian surface. Which describes flux and stuff. Isn't that right? Isn't that right? I have to do my research to put that up. Look, isn't it cool? Isn't it cool? I have several friends, and you're one of them, okay? That's how it works. So, say hello, say hi. Yes, thank you, Oni. Just say hi to Gauss. Nep has 1. That's Gauss's law. Gauss's law is completely different. Gauss's law describes... shoot. Been a minute. Gauss's law. For magnetization. It's a little different, right? It's a different flux thing, isn't it? That's Gauss's law? Okay, I gotta run it against you real quick, right? Because I thought it was something flux related, but you did not express it very well. I looked it up and everything. Whatever. But yeah, Nep has 1. Z has one. My friend Zuzu, she raided me the other day. She has one. Penbu has one. I should do one for anyone that's in the chat right now. Komi, would you like one? Karmamos, would you like one? Oni, I suppose you're here. Would you like one? I just don't know how to make it personalized. Just for you guys. You know, it's like a little hello. So, take one. Maybe I should submit it. Maybe you guys, I'll have a... Oh, I should make a Google Forms. And you guys can submit it, your command. And I'll just have to be like exclamation point this. And then you would have to be included. And then I'll tell you whether they work or not. That way, I don't have to like manually find out what you want. Or you can just describe what it is for yourself, and then I'll just be like, yeah, that looks cool, right? So I'll have to accept pictures and stuff like that. Can you have one, but a wrong one? Like it wouldn't even work because it's syntax error. You want specifically one that won't work? That'd be funny. Entirely up to you. Don't know what to be. Thank you. Yeah, I'm not sure how. I think you're new, so I don't know how much math you know. So just tell me what the idea is, and then we can make it work. You like $1 right? Okay. Yeah, we'll do that when we do it. Okay. Anyways, back to our math real quick. So that is a second multiplication, right? And we're done with the multiplication for 0. Okay. Now, when I work with students, I usually describe it like this. Okay. We're gonna start now at 2, but the issue is we are not starting at 2 because we would start right here, but that's not the case, right? 𝖈𝖗𝖊𝖎𝖎𝖎𝖙𝖘 is Gauss's law for magnetism. I thought so. So you're lying to me. I gave you something, and if you say I'm wrong, correct me because I think it's funny. Okay, so what I usually do is that I don't say we're start here. We don't add a 0 just to keep things simple for them. I just say we have an x. We're not starting here. It'll be replaced with a 0 later, but it'll keep the numbers different. Okay? The integral form is equivalent? Really? Goes to show I only take ENM1, so suck it. Okay, 2 times 9. Tell me 2 times 9. Let's go. You know a lot about this Gauss guy? Wait, your name is... I was keeping it... Hold on. No. I did not get out-nerded. I kept up very well. I'll have you know. Oh, let me roll over volume 2. I kept up very well. I can speak to Gauss at a peer-to-peer level. That's, again, it's been a minute since I've done any magnetism in real life. So why would I happen to know most of these things? Besides, flux. No need to flux, but like, come on. That should have been the pun. Come on, you should have done that. I'm also having a bit of wine tonight. I chose to get some wine. There you go. I don't give a flux. See, that'd be good for your name because that sounds relevant to Gauss stuff. Okay, 2 times 9. This is the hardest question ever. $18. Okay, that's 18. We're going to carry the 1. Uh-oh. That looks like we're going to have to add something soon. So, yeah. 2 times 6. What is that going to be? $12. Uh-oh. But we have to add the 1 now. So, what is 12 plus 1 going to be? $13. Wow. So we get our first addition just for this scenario, okay? Uh-oh. So we get 12, 13. Why are we doing multiplication? To emphasize how easy it is to do multiplication and what operations we end up doing. Well, we're not done yet. Okay, last one. Because it's math, okay? Because it's easy enough. Everyone's done their basic times tables. They should know this from like 3rd grade. Okay? That's a big math point. Okay, 4 times 9. 4 times 9. Explain to me now. What is that? We're not starting here now. We're not starting here. We're starting right here. For those that don't know their math. 4 times 9. Let's see. 27 plus 9. That's crazy. Actually, you know what? Let me show you this trick too. Okay? I often show some of my students this, but it happens. 36, yes. So, we have a 6 here, and then a 3. Until the times table is up to 10. Really? That's all you need for a second. Actually, no, that's not true. So that is going to be 36. Okay? Now, here's something interesting about 9, okay? While I'm here. Okay? 1 times 9 is going to be equal to what? Actually, let me just say it because I think it's going to be kind of sucky. Okay, 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is equal to 27. Then we have 36, 45, 54, 63, 72, blah, blah, blah. Okay? Now, what I often show students when they're just learning is with patterns of 9, it's kind of chill because you look at 18 and you look at 27. Okay? Something weird happens where you can identify a pattern that looks like this. Just T enter the equation. Don't worry about it. The first digit goes up by 1. And the second digit goes down by 1. Yeah, basically 10 plus 1. What? Now, better than that is not just that. So you can tell if any number multiple is going to be available. It's Nepenthes. Did it work? Did it work? It did not work. Ah, maybe you can't use it for replies. Now, what if we add up the digits? Who knows the digits? What happens if you add them up? 1 plus 8 gets you what? Oh, something broke. 9, okay? What about 2 plus 7? What does that add up to? Music died. 2 plus 7 is a special one because it just gets us 9. Okay, so pattern recognition. You can't say it for the next 30 seconds. Really? Why? That's weird. This adds up to 9. 3 plus 6. 4 plus 5. 9. 9. 9. 9. Okay? Now, for those of us... Oh. And you spice it up. Say, it is 9. It's 9. The number is 9. The answer is 9. 9 would be it. You gotta be creative, my dude. So, gotta get around those filters. So, the sum of the digits should be equal to 9. Now, technically. More specifically, it is multiples of 9. It's divisible by 3. Lars is bigger than. Do double $. It'll auto format in the middle of the page. It's really cool. 67 times 0 plus 9. Yeah. Okay. Basically. Anyways, let's keep this up real quick. I just wanted to share that little fun tidbit. We can prove that in one time, but later on. So 36. 4 times 6 is gonna be what? I don't know. 1. Fine. I'll do it for you. Okay, 4 times 6 is what? 24. There, that's how you do it. It's auto formats. It automatically fills in the entire space with it. Nerd. Okay, that's why I asked you. Nerd. They're not even a real fan of Lars. If he's so much superior. Wow, it's smaller. Well, yeah, but you can read it. Okay. 4 times 6 is going to be 24. Correct. Plus 3, though. So 24, 25, 26, 27. 27. Okay? And then we carry down the 2, and that's going to be happening. So we added one more time right there because we added the 3. Okay? Now we have to add all these numbers up together. So how many operations is this going to be worth? Also, I totally forgot to keep track, but basically we have 6 multiplications. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes. So this answer, we add them up. Technically, there's 3 additions right here. So 1, 1, 2, 3. 3 more additions right here. 1, 2, 3. That's gonna be 8. 1, 2, 3. How many additions right here? 3 plus 6 is how many? Wait, I just realized that's not right. We had 2 additions, not 3. My bad. Okay, how many additions right here? You need math insurance for all these operations? I know, right? We do 1 more operation right here, 9. So that's 1. 1 plus 7 is going to be 8, which is 1 addition. And then the last one is 2. So the final answer is going to be 1. Yeah, because they're all between it. So we should count 1, 2, 3, 4, 5, 6. Hold on. 1, 2, 3, 4, 5, 6. Guys, I'm going to say it. 7, and then 8 from earlier. So we have 1, 2, 3, 4, 5, 6, 7, 8. So the numbers match. Yeah, basically. So how many operations did it take to do this 1 multiplication? Let's just count up the answer. So this is equal to 1, 2, 3, 4, 5, 6. 6 multiplications. And this one here took 1, 2, 3, 4, 5, 6, 7, 8. Which ironically adds up to be a total of how many operations did we do? Just for this 1 calculation. Oh yeah, I forgot about that one. Gauss, you exploded me? Excuse me? Yeah, I added that last stream. That was actually really funny. Let me call it too. I'm gonna make you explode. Watch this. What the hell? That wasn't fair at all. Damn, that's good. All right, I exploded twice apparently. That's good. What are the odds? Hold on, I'm looking at what our numbers are right now. We have about 10 people in chat right now. That's crazy. So 1 in 10. Once our odds get a lot smaller, then it's gonna be even funnier when things like that happen, right? Oh man, that's gonna be great. Use your Lars laser. I don't know this. Okay, so it took us 14 operations to do some quote basic math. Now I don't blame people. It's not statistics. Statistics is when you start like taking square roots of baloney, which by the way we're gonna cover how to do today again. I'll brief it. So yeah, it takes a lot of operations to do something like this. Now division, if I did it the other way around, 3-digit things. Who happens to know? So let's do 2,890. 28,980 divided by 500 and 420. Okay. How many operations do you think this will take? Now, what are we actually doing, by the way? Probably like 14. You think it's gonna take like 14? Maybe. We can reduce it. We can reduce the fraction because here's what we got: 420 divided by. Wait, the other way. 28,980 divided by 420. Wow, good number. So let's reduce this by 5. Okay, let's just be comfortable and divide this by 5. Who happens to know how to divide this by 5? What's 420 divided by 5, folk? The irony, though, is that we are, in fact, dividing each individual number and doing some wacky stuff to actually do stuff. That's the thing, okay? Maybe I should demonstrate it with a simpler operation. 4 over 5 is the same as 840 over 10. Not that, not over 5. I said dividing. Oh, wait, I see what you did. Okay. Then you reduce it by 10 to get 84. Is that the case? Because what is 420? 60? Then you reduce that, and that's going to be 6. 84 over 6. May I missed a negative sign? What negative? Okay. All that to say is that when you divide out 5, first off, just even doing this one, 28980 divided by 5 means you are, in fact, still doing the operation, right? So you can't do this into 2. Let me use the golden one. Golden one. Okay. So yeah, you can't do it into 2, so you extend it to 28. How many 5s go into 28? Well, 5. Okay. So we did 5 times 5 then. So our multiplication is in fact going to be increasing by 1. Our addition is going to be increasing by something else. Okay. So we would still be doing operations if we want to reduce things. Everything takes operations. Now this gets into numerical analysis and algorithm analysis. So that's when you start optimizing for things to make them good, right? So who's ever actually taken a algorithm analysis class? Who's ever taken that before? Nope. It's okay. 𝖘𝖔𝖈𝖎𝖆, you have? Does the stream count? The algorithm? Yeah. Computer engineering undergrad. Ah! Comp engineering. Gauss, do you even know what that is? No, of course not. You didn't have to take it because you were a physicist.
Hi guys, I did physics. I did general relativity and thin films.
And spectroscopy. Stuff like that. So yeah, this is where we get into big O. Big O notation. The worst case scenario. No, that's not worst case scenario. I think it is best case scenario. No, it's still worst case. It's one of them. I think big theta. Let's see. We had big O, big N, big O, big omega, and big theta. Best case, worst case, average case. Yeah, theta is average case. Yeah. O, like the O symbol. Okay. So the function you put inside of it, you're saying the function, the algorithm describes something very natural, okay? So let's talk about the operations with addition, subtraction, multiplication. Let's go back up here then, okay? If it took us 6 multiplications and 8 additions, if I remember, I'm inclined to say that all these operations, compared to the number sizes, multiplication depends on how big your numbers are and how many digits each of them have, right? So I believe that's what, n squared? Because you have n many digits right here, n many digits right here. N times n gets you n squared, more or less, right? But if you don't... Is that right? You can't cheat on this one. Can't cheat on this one. You have to do it. So, I believe this describes, it takes a lot of operations. So the actual operations, I think a big O of, I want to say n squared. That might not be right. I think it's log, no, that's not right either. Let's just say n squared, just for the sake of argument. So we're saying that for really big numbers, it describes a parabolic description, okay? If it was something in big O of n, then we know it describes a very linear relationship. And this is below it. Let me use a pink real quick. Technically, in all cases, after 1 right here, n is lower than n squared. Vaguely remember the parabolas in school. Parabolas, yes. Okay, so they basically get bigger. They're bigger than the straight line. Okay. I'm not a parasocial with this streamer. I'm parabolic. That's a good one. That's a good one. 𝖘𝖔𝖈. That's a good one. Yoink. I'm making a... I can make that into a thing real quick. But for sake of time, no. I'll do it later. This is 𝖘𝖈 with a brain cell. Is that right? Okay. So, which looks like the bigger function? Which one looks like the better one in terms of, like, below? Which one is the bot, if you will? Right now, the bot is good, okay? Being a bot is good for functions, alright? For this scenario. So, which one's the bot? Bottom one. Yeah, the bot. Like, the one underneath. It's funny. Which one is directly below the other one? At least past this point. Anybody? Anyone? Anyone? Yes, the purple one. Thank you, Oni. Where'd you guys go? Tyler, are you working or something? How dare you? So yeah, if we have a function that's underneath this relationship, that means it's better. So in other words, it's playing 𝖉𝖐𝖎. Okay. So big O of n is lower than big O of n squared, which is good for most cases, for operations and stuff. Now, there's other kinds of functions, and they get significantly worse as you go. So yeah, the division algorithm, I'm just going to go ahead and look it up. Let me look up long division. Long division algorithm, big O. Big O time complexity. That's what it is. Time complexity. It's very inefficient. Ooh. Ooh, we have a whole Wikipedia article for this. Guys, check that out. Let me see. And let me check studio mode real quick. I'm just curious about something. Yeah, that works. Okay. So, how complicated are the actual mathematical operations? How involved are they? Okay. So, over here, let's take a look. Addition is in big O of n, which means it's a fairly efficient algorithm. However many numbers you have is however many numbers you're actually playing with. Sure, okay. Subtraction's big O of n. Depending on the multiplication method, there's different ways to do multiplication. So, big O of n squared, long multiplication, different algorithms. I don't even know what this one is. N to the 1.5, that's weird. Tom Cook. This is yeah, this is very interesting. Now division. Division looks pretty interesting. So like n log n, n log log n. Where's Nep? Guys, tell her that this multiplication method has many log. It's got so many logs per second doing this one. This is a joke right here. And hi Nep. Log. Big O of n log n, log log n. The fucking logged. Which actually is curious. I'm curious what this algorithm method is. Applying. Oh, it works recursively of applying the fast Fourier transform. Gauss, are you here? Hello? It's about big O n log log n. Log, like the one for Clash Royale, added to math. Yeah, they added the new card. It is meta right now. Yeah, totally. It costs 7 elixir. which isn't very like computationally good. Yeah, FFTs do multiplication, huh? Yeah, don't you know? Which by the way, log n is actually a pretty much better algorithm than log n. Most of these other ones, n squared is buns, right? I think I was right when I said this. It feels like bringing ICBM to the knife fight. An ICBM? Why not? You want to win, don't you? Okay, now division. Division can suck. What is... Oh, that's interesting. Big O of n squared, sure. Long division. Or you could do big O of mn log n. What is mn? I actually don't know what mn is. And by the way, this is a graph demonstrating... this is a graph demonstrating the way some of these functions... We want low functions, okay? We want better functions like this. Big O of 1 is impossible. But it's like... Imagine if you could just like... Snap your finger and it's solved. That's the algorithm method. Instantly solve it. Sure. Log base 2 of n is pretty good. Square root of n is really good. N is the baseline because usually if you have like 10 things and it takes you 10 times to do it, that's pretty standard. Now the rest of these are buns because they are actually very bad at scaling. So back over here, I want to know what this mn is talking about. Hey, look, Newton's method for square roots. Guys, it takes big O of mn. Remember when I did that? Guys, remember when I'm going to cover this today? Isn't that crazy? You have Lars time. He hates to look at the screen. No worries. Touche. Yeah. Newton's method. Apparently, that's the only way we can solve square roots by itself. Modular exponentiation. Exponentiation. Repeated multiplication and reduction. Yeah. Algebraic functions, polynomials and stuff. These are so cool. Yeah, callback. It's like we're going to do this again today. So anyways, yeah, I was just curious about that. So it's in big O of mn. Which, by the way, big O of mn, let's find that. M of n. What does that mean? The divided mn below stands for is a stand-in for the complexity of the chosen multiplication algorithm. Oh, so that's multiplication. So however method of multiplication I use, then that's going to be used for the algorithm. Which makes sense because the biggest issue with square roots right now, let's go ahead and do a sample problem with the square root stuff. Okay, like actually go back to it. Okay, all that to say, computationally, it is kind of difficult to do some things, but nevertheless, we still have to compute it. So let's take, for example, this algorithm right now. Okay, we have a function. Okay, we are going to solve for the square root of something. I'm going to do the square root of 2. Now, there is a function, a Newton's method. Which actually comes from numerical methods. Okay, I did not take numerical methods. I am not a applied mathematician. That is just something that I learned recently. So I am better than applied mathematicians because I can actually prove stuff. I'm better than them. Square root of 2 is in the rationals, of course. Wait, no, it's not. No, it's not. You're a liar. No, you're a liar. You got me. I couldn't read that. You are a mathematician that actually does work. Shut up. Shut up. I may not have a job, but I have passion, okay? It's different. Huh. Okay, Newton's method. Screw you guys. Watch this. All right. So we have a formula. The Krabby Patty formula. Here's what it looks like, okay? We have a function. We're saying x squared minus n, okay? That is going to be a function. We have this chunk right here is the actual computation. This is something you do. And then over here is the goal, or I guess the it is this bit. Which means it is the argument of your square root, okay? So if my number, which I'm going to plug in, okay, I don't know what that is. Don't know X. So if I don't know what X is, I still have to plug in something. And if I subtract it, then I'm trying to get it to be as close to 0 as possible. In other words, if I am, let's say I have a pitcher of water. Okay. And I'm filling it up with water. Okay. I'm eyeballing some of it. Okay. Now, I know this entire jug weighs about, or it contains about like 1 liter or something like that. 1 liter of water. Okay. Very good picture. Thank you very much. Now, if I said the whole thing weighs about a liter, okay? But I want specifically half a liter. Now, I could weigh it out, and that would suck. Thank you. I am hydrating. Let me drink some. Is this gonna happen today? Okay, you can only drink the pitcher. And if you stop, it needs to be as close as possible to 1/2 liter. You got to drink half of a liter of water. Now, how do you know? Okay? You're going to have to do a method where you are guaranteed to find out. But when you dump the water, you get half of it. Okay? That's like the kind of guess. Now, whatever you end up with, okay? Let's say you end up with, I don't know, like, about this much. I'm going to say about like 0.7 liters. Okay? So, if I subtract it out, 0.7 liters minus 0.5 liters, that's a rate of about 0.2 liters, which means I'm this much off. So if we're doing like some sort of like Squid Games level game, I want the person with the closest number to 0 in that scenario. Whoever has the biggest number, they die. And it'd be really funny to just keep doing that ad infinitum until you get like 3 people or something like that. Does that make sense? We're trying to get your guess. This is your guess right here. You actually trying to drink this stupid water, I guess, with this analogy, to actually get as close as possible to the goal, which is 1.2 or 1/2 or 0.5. It makes sense. So to do that, we take the difference. So that's what we do with our guess of X. Or more specifically, it's going to be X0 because for right now, we're trying to get a number. Okay? Now, Newton's method says this. We have a function. Okay? Let me do one that looks like this. Okay? Except here's the issue. We don't actually know the rest of this function. Okay? All you know is where it ends, right here. Got it? So, at this stage, what you can do, you can take the derivative. It's the Vtuber live. It's A. How's it going, A? So what I'm drawing right here is the actual path of the function. However, I don't actually, and let me actually make this a little different. Let's say I know for sure later on it goes up, but I only know this point. So Newton's method states that if I take xn plus 1, I can take a last step right here. This is going to be xn. I can take my last step xn and subtract it with where it's currently at right now, the function of fxn, where it's literally at right here, minus its derivative, its rate. Okay? So imagine if I had said, I read your speedometer at this exact moment. Now, I expect you, at this point in time, at that rate, to be going that rate. You're not going to be changing nothing. I don't expect you to be changing nothing. You better not. Because if that's the case, then you are changing my data. So what ends up happening is that your next time step will get closer and closer. And we're actually going to go to a different... So let me find my different key. we're actually going to be doing a function that looks like this. Even though this is not the right one, we end up doing a different one. Got it? Now, Newton's method still uses this. Okay? So, to get a predictive square root algorithm, I need a number to be as close as possible to 0. Then what I end up doing is creating this function. F of x is this x squared minus n. So now let me go ahead and move some of this stuff over. Shoo. The Vtuber. Okay. I'm getting better at this paint stuff. All right. Now, question for the chat, fellas. What is the derivative of the function right here in terms of x? And I can tell you 2x. Now, if on your mother's life, or father's life, or your life, or your friend's life, are you sure? Because here's what I'm going to do. I'm going to gamble an explode command. Go on your life. Tyler's life. You think so? Let's explode. 𝖘𝖔𝖈𝖎𝖆𝖕𝖎𝖙𝖘 has exploded. I apologize. That's a bummer. So, yeah, that's blood on your hands. I hope you understand that. But you are correct. Well, I guess, huh? People don't die because of the bet. I think I misunderstand the concept of the on people's lives kind of thing. Okay, yes, the derivative is 2x. So when we combine it together in this function right here, she exploded again. She or he? 𝖘𝖔𝖈𝖎𝖆𝖕𝖎𝖙𝖘. I feel like that's a she name. You exploded twice. Rip. F prime of x is equal to... wait, no, that's not what I want. So we plug in the things that we know. xn plus 1 is going to be equal to xn minus all of f of x up here, okay? This bit up here. Call me, we're never followed. What? I meant thank you very much for the follow. I appreciate it. We're getting one step closer. Guys, if we just hit at least 200 followers by the end of the year, then I can finally tell my parents that I made money on this project. Yay. I know 𝖘𝖔𝖈𝖎𝖆𝖕𝖎𝖙 has died now. That's a bummer. Okay. All that to say, okay, so we have xn minus quotes xn minus n divided by 2x. This whole thing is quantity minus. Okay? Very, very painful. Apologies. You got the follow. That's all that matters. Yeah, I guess so. Which, by the way, ad break in 3 minutes. Now, I did some of this work already. I did this derivation. And that is on my notes back over here. That's the derivation back here. And this is the answer I got right here. Which, by the way, taking notes live is actually really fun. Because I didn't realize how possible it was digitally. I prefer notes in person, on paper, physical paper. But obviously my medium can't do that. So, at least not right now. So, yeah, we're going to do this. So here's the actual formula. So, I'm going to copy this right here. Copy that. Go back to the very top. And then I'm going to go put that right over here. Hold up. Yeah. You get a notebook for streams. If you want to. I mean, do you think I'm doing a decent enough job teaching this stuff? I'm kind of just blabbering out loud. It's basically like a Socratic seminar, except with different philosophy and methods and stuff like that. Yeah, that's chill. So our final answer is actually going to be this equation. xn plus 1 is going to be equal to 1/2 all this stuff. So for the square root algorithm, let's go ahead and solve for the square root of 2. Okay? Actually, and that's good because it's on a different layer. Okay. So all this to say, to solve for the square root of 2. So let me write it back over here. Xn plus 1 is equal to this stuff. And I'm going to erase this. You made them both cry. Wait, got one for Nev's plant ones, and then one for Mylan's statistics streams. Oh, I see. I didn't know that. Well, you're learning. This is not going to be homework on the test, but maybe I should probably have something like a quiz command at the end of the thing, so you guys can do it. That'd be really funny for channel points or something, or subscriber status. What can I do for like following the lecture and then you guys actually get to try it out? Which, by the way, I'm gonna snooze you. Go away. It's a good idea. Aleph, you're thinking. You're thinking your big boy brain. 3 degrees over here. Finally thought of something cool. Yeah. Okay. Okay. Square root of 2. Okay. Squirt 2. That's what we got. So we need to do a guess. Like I said, we need to guess a number. Okay? Now, to guess a number, we already know 2 things. And I like using this example. 1 squared. Let me use gold. Okay. 1 squared is going to be equal to 1. Which means that implies that the square root of 1 squared is going to be equal to just 1. Duh. Of course, the squares cancel. 2 squared is equal to 4, which implies that the square root of 2 squared is just 2. Now, where does the square root of 1 squared, or let's just look at the answer. Square root of 1 lie between 2 and, yeah, but what am I saying? Square root of 2 between 1 and what? Right? Between these 2 numbers, right? 2 is between 1 and 4, which means it should be between it. Now, what are the actual values for these answers? Okay? That's the same as saying it's between 1 and 2, which of course means we can do a guess of any other numbers. 𝖘𝖔𝖈𝖎𝖆𝖕𝖎𝖙𝖘, you're getting ahead of me. Yes, thank you very much. Hold on to that thought, okay? Okay, so what's a decent guess for x0? X0 is going to be equal to a guess, which is going to be what? Is there a way to do a palette? I don't even know. 1.5. Do you think 1.5 is an appropriate guess? Yeah, right? 1.4, 1.5. Who else is here? 𝖘𝖔𝖈𝖎𝖆𝖕𝖎𝖙𝖘. Between 1 and 2. Yeah, we'll do 1.5 just to prove a point, because it's actually really convenient to do. 3.14? Wrong. Sorry. That's pi, in fact. Oh, actually, it's 7/11? No. Okay, oops. Okay, here's what we need. So we're going to use a guess of 1.5, okay? Which means for our Krabby Patty formula back over here, which you're going to copy, I'm going to write it out. That means the next term, xn plus 1, is going to be equal to 1/2 xn plus n over xn. I know to remember. 1/2 do xn plus n is going to be the number 2 over xn. Okay? For right now. And xn is going to be 1.5, so let's plug it all in. That's going to be equal to 1/2 1.5 plus, I'm going to keep this in terms of yellow real quick, 1.5, and then 2. Okay, now let's divide by a fraction, okay? 2 over 1.5. Now, this is elementary. Everybody has learned this once ever in their lives, so everyone totally knows what to do. That's why I will be the layman and act like the child in this scenario so you guys can make fun of me. That's totally why. So, 2 over 1.5. If we don't know how to actually divide this out, we would be doing this. 1.5. And is that possible? Do we know our multiples of 1.5? We have 1.5. 2 times 1.5 is 3.0. 4.5. 6 points. That's very inconvenient. We're not going to use that. So if you thought of using this, that's very not smart. I mean, you could do it. It's very possible. It's not a big deal. So let's get rid of that. Instead, we should be thinking of reducing it to a whole number. So there's several ways to do it. If I can make 1.5 into a whole number, I could say something like 15 over 20. Sure. Or you could have also seen that 1.5, it's probably into adds right now. 1.5 is a multiple. If I multiply by 2, I can get 3. And then if I multiply 2 over here, then I can get 4. 4 over 3. It's not 15 over 20. 20 over 15. Flip it. It's the reciprocal. So that means, or if you look at this like this, 1 1/3, which is the same as saying 1.333333333333333 repeating, right? So now we know that answer. So that whole thing is going to be equal to, and this is our thing right there. So that means this bit is going to be 1/2 times 1.5 plus 1.3333. Let's do 4 just for a second. Now, when we add these up, we don't have to be too particular. We already know that's going to be 2.8. And then the rest are 3s. Everyone on board, give me a thumbs up emoji or type explode in the chat if you understand. All one word. Okay, the bot has exploded. Who else is paying attention? Who else is gonna explode tonight? I'm gonna explode someone right now. Alex _ hello. I haven't heard that name. Oh, they're probably in ads, I just realized. Why would I have ads for a lecture stream? Gotta get that bag. If you subscribe to twitch.tv/alephmuvt, then you can also avoid ads and participate more in this stream. That's right, guys. If you get if you get out of ads by subscribing to twitch.tv/alephmuvt, and you too can enjoy all of the fun content of math streams without any of those pesky ads. Now, there's several tiers to that, and that comes with all sorts of wacky perks. That includes probably custom chat commands, custom emotes, and more importantly, a VIP status for my stream emblem, which is my jacket semblance, which you can see right here. That's what that is. That's what that is. You are now part of the alephmuvt set. You are joined the set. You are now adding to the cardinality of it. Very cool. What'd you say? And wait, what is happening? I don't get it, but I'm mostly... Do I really have a soothing voice? I really don't think so. He's got a soothing voice. Hello. Hello there. He's a cutie. Poisson! Guys, Poisson. Type Poisson in chat. Exclamation point Poisson. He's a cutie guy. Exclamation point Poisson. Didn't expect to see you on the Vtuber, the Twitch side. It's supposed to have I'm supposed to work on the other end. Oh, I see what happened. You said hi, and I didn't get to say hi. Yes, if you use exclamation point, yes, there it is. There it is. There it is. Good job, 𝖘𝖈. Thank you. It's Poisson. Poisson's in the chat. The croissant is here. Okay. Croissant, tell us, please. Poison Ivy. Tell us what the... Yeah. Poisson. That's you. I want to put more commands on that to be cool. All right. Take 2.83 repeating and divide it by 2. What do you get? That seems to be like the honorary name. I personally like Poison Ivy because it's like poison invariants. Poisson invariants. Okay, never mind. I'm alone on this one. All right, cut this number in half. 1.416-ish. Okay, 1.416 fish. That's what the fish asked. That's what the contribution is. You cut you in half. Cut you in half, you fucker. Hey, no bad words. Tyler, stop asking questions. Okay. Wow, look at that. That is the final answer we get from our guesstimate over here. So we're saying that the square root of 2 is just about it's about this much. The square root of 2. Is that the case? Want a cutie command? Should I have a cutie command? Yeah, probably. Now, the real answer of the square root of 2 is actually 1.414 something something repeating, okay? And that is, in fact, the square root of 2. Pretty convenient number. Pretty convenient. Pretty convenient. Lars eating your walls nonstop, looking at the screen. What is this? What is this little chimichanga doing? Poisson, question for you. Did you know, and we were just covering this a second ago, where's my other page? I'm gonna put this over on my... Oh, crap. That's not what I wanted. Give me a second, give me a second, just give me a second, give me a second, give me a second. All this word stuff, I apologize. I don't know what it sounds like or anything. Well, now I should really confirm switches. Okay, did you know Poisson croissant invariant? What am I looking at? Not that. Okay, there you go. You can see all the secret folders. Do not, please. I very much have my... I don't have secrets. No, I just don't want you guys... I have privacy. That's what I want. Okay, take a look. The time complexity for solving some of these algorithms is actually not that bad. But it's still a pain in the butt depending on what you do. So, we're talking about how addition is in big O of n time complexity, which is fairly standard. You still got to add up all the numbers. You got to go through each number one at a time, of course. Now subtractions in big O of n. There's no way about it. You can basically just do this. Now multiplication has several wacky methods, and apparently the best one of the better ones. Actually, which one is the best one? Normal multiplication is in big O of n squared. That is the worst. That is the worst algorithm. Now, the 𝖘𝖔𝖈𝖎𝖎𝖙𝖘 algorithm looks like it's in big O of n to the 1.585 for whatever reason. Through 𝖘𝖈𝖎𝖚𝖑 multiplication. We could look into these at some point. That actually sounds so cool. Why these are different. 1 digit, 2 n digit numbers. Okay. Now, all these are very different ones. Nep's favorite so far is going to be the Strong-Hange Strohong-Straussen algorithm, which is big O of n log n log n, right? Log. Now, it's something interesting about division. It's some of them depend on old school division isn't big O of n squared, or depending on your other division algorithms, they actually have a multiple. This m of n is actually describing which multiplication algorithm you're using. So that means if you're using a multiplication algorithm that takes n squared time, then it's going to be n squared log n, or any of these ones, right? So let's say I wanted the best one, n log n log n, or this looks like the best one, n log n. That looks pretty good. Suzu, hi Suzu. Last night's stream died because the internet broke, but today I'm back at it. We're learning that our classic school book way of doing multiplication. You know how we do multiplication one step at a time? It's the most inefficient algorithm for everything. Also, how do you know each other? So take a look. The square root algorithm is actually entirely dependent on your multiplication algorithm, which is pretty interesting, which still only uses Newton's method. So Poisson, I figured you would like that. Pretty cool stuff right there, eh? Now I also wanted to show off while you guys are here. Where did I show more things? It's blowing up more people again. I wanted to show off the thing that I made last night, or the other night. This was the I made an animation the other day, and it was really cool. Oopsies. Oh yeah. That's what I did. So I made this. Break it down, Fractal boy. That's me. That's a Fractal. I'm the Fractal guy. I made this animation. I figured it'd be really cool to actually do some animation stuff. And in fact, I'm learning how to do it. So that is probably going to be the next transition right now to show you how I actually made this video. What? And with the sound effects and everything. The sound effects I did one at a time. It was pretty cool. It got 2,000 views on YouTube. That means I peaked, guys. I'm actually a little disappointed by the number, but it's pretty good for what it was recently. Yeah, woohoo! That's pretty good, baby. I'm basically famous. Poisson, though, I'm not gonna lie. That one video that you have, let me pause this real quick. That one meme that you did the other week was so funny. It was literally just the funniest thing ever, I thought. Let me bring this back up. You know the one which is like, hey, give me a, what was it? Give me a how does it start? Give me a VTuber. VTuber, got it. And make him do math. Safe for week. Safe for work or something like that, dude. Should I pull it up? Am I allowed to pull it up? Hold on, what? Oh, okay. Hello, you buy a ticket to join the stream by calling Aleph a cutie. Al, you're cute. Okay. Thank you guys. I am very bashful when you guys say stuff like that. This all started with a nap. I know what you do. Guys. Okay, I'm pulling up the thing because it's really funny. Okay. Okay. How many people are we gonna do doing this? Okay. I'm pulling up Poisson's. I'm pulling up your funny meme video. It's really good. Okay? And everyone, we're going to watch it together. And it's going to be funny. I'm sharing it on audio. I'm stealing views right now. Okay? What are you going to do about that? Yeah, I know. It's not like it was actually one of your most popular videos for some reason. As of late. Because it's just straight up a meme. It's so good. You know the one I'm talking about, right? The pizza one. It's so good. Okay, I'm pulling it up. Yeah, okay. So good. And I didn't know there was more Math V people. If only it works. Stop it. Okay. We have it right here. Gonna center it. And then now I just gotta lower it, and we're gonna hear it together, okay? Okay. Always on the prowl for more math VTubers. I'm surprised you don't know of one. Do you know 𝖘𝖔𝖘𝖐? He just did the Romanjian not too long ago, and did another one recently about like some stuff about. Okay, anyways, we're gonna go ahead and watch. If you don't know who he is, then I'm a step ahead of you. There's more. They're multiplying, if you will. Haha. Or I guess some sort of wacky time multiplication method. Haha. Joke. Okay, let's go ahead and watch because this is great. I'm looped on loop. Okay. All right, get your popcorn, guys. This is really good. Are you excited for this one? Okay, let's see if it plays. Okay, let's go.
Hey Fred, give me a 𝖘𝖔𝖈𝖎𝖑𝖘, and keep it safe for work. Safe for work? And make it about math. Make it about math? Hey Jimmy, give me a twink with no audience. No audience? Hey Fred, give me a 𝖘𝖈𝖎𝖑𝖘, and keep it safe for work. Safe for work? And make it about math. Make it about math? Hey Jimmy, give me a twink with no audience. No audience?
No audience. Oh my gosh, and that was one of your more popular views. That's so good. I like this one so much. It's so good. Following this, I actually really wanted to do one of the Metal Gear ones. I wanted to do the bit where it's like, oh, that's a nice argument, physicist. Why don't you back it up with a proof? My proof is that I made it the fuck up. Something stupid like that. That's really what I want to do next with my edit. Someone put that together. But yeah, I thought that was gonna be really funny. Which, by the way, we also didn't cover today's. Well, we didn't cover today's theorem of the day. My proof is that I made it the fuck up. It's great, Terry, guys. Okay, Suzu. Oh my gosh, everyone's here. Suzu. I'm gonna use your commands. The bellflower is here. Terry, use your Terry command. It's great. Gotta go to bed. Who needs a brain cell? Pass the brain cell off to pass it off to friend. Yeah, it's Terrified Games on twitch.tv/Terrified Games. Oh my gosh, guys, it's so much. It's like seeing a high school reunion, but like we didn't do anything. Pass the brain cell off to Tyler. It'd be really cool. Terrified Games. I apologize for not being available. I happen to have been working and/or preparing for stuff. So yeah, let's go ahead and move on over to my Blender screen real quick. So I was washing my car. I was basically washing my car. Okay. It's now dust free now. Is that right? Let's see. Okay, let me actually show you what the behind the scenes for this video was. Remember, it is the Z one. I cannot find for the life of me where the audio is for that. Lars. Oh, duh, because I can't find inactive sources. Huh, silly me, guys. This has to be spelled Z, so it's the last one. So, what am I gonna do? I'm gonna show this off real quick. So the way that I made this video, you keep it in the corner. So this entire project, every time I move my everything behind the scenes is super laggy. Okay, so there's a reason why all these little dots right here exist. Those are individual vertices. So if I were to click it, then I can drag it around. I'm actually stop it because I know it's gonna break my machine. So let me demonstrate with something else, okay? So guys, this is actually the most difficult shape in all of mathematics. This right here, the infamous flat looking, but like in different angles thing. I forgot what it's called. Maybe some of you guys can give me a hint. Give me a hand breaking this down. What do they call this thing? A rectangle? I think you're right. I'm just gonna call this the Amazon delivery package, because that's the only thing I really don't know. Default Blender square. Oh no, that one's been long gone. I deleted it a long time ago, and then I've reconstructed it. Yeah, this is it. Is that a hypercube in R3? Oh my gosh, you are basically correct. Anyways, so we have all these individual vertices. Okay. Vertices are very handy, very good. Yummy. We love vertices. Yummy vertices, okay? Now, I can do all sorts of manipulation with this stuff because these faces, if I were to triangulate faces. If I were to show you guys like what they're actually doing, everything turns into triangles in the end at some point somehow, okay? But let's not worry about that, okay? What ends up happening is I have a fun little thing. It is called geometry nodes. So every single vertex that I have here is going to generate a smaller version of itself. Exactly where the... Hold on. Points. Mesh 2 points. Sincerest condolences, tell me. Verts are yummy. What are you talking about? Okay, observe. I have reduced the weird looking square thing into small little balls. How is this possible? Well, it turns out that what I just did is I turned all these faces into all those vertices into an instance of something cool, right? So if I had a really complicated shape and all I really want are the vertices, this is how I can do it. It's just metric balls. Metric balls. Quick, someone calculate the tensor on this the metric tensor on this nonsense. My dog wants it. Okay. All that to say, tries to quad. I'm gonna go back. Okay, so we can see exactly at each corner we're gaining something cool. And what's something cool is that if I were to add more vertices, you can see that it generates more of these balls. Now, we don't necessarily need the balls for ball data. We need the balls for where stuff is going to go. So what ends up happening is I'm going to make a smaller version of the thing right there. Wow. Ball data. And if you just keep doing this repeatedly, then you get this interesting shape. Actually, hold up. Let me go back a few. So I can actually join. And then it says 2 instances in. So that's how I get this very interesting, wacky image. All the data is going to be new Discord status. Huh? Oh yeah, by the way, my machine is completely frying right now. It's thinking. It's thinking, fellas. Look at that. Look at that. It's calculating all those individual arrays and all those vertices and all that data. And it keeps doing that tons and tons of times. Now, I can't afford all those frames, so I'm going to just turn it back into a solid. Okay? So I get this really cool thing. Yeah, if only had better specs. But who needs that? So all of these individual shapes right here, this is called the Meng sponge, okay? So let me show you with an example of another kind of object right over here. Now, there's 2 different kinds of nodes that I did. The one with the balls, so it can make smaller instances. Oh no, I just realized what I did. This one has way too many vertices and it's going to calculate for quite a long time. Oh, if I had 6 last time and then I kept basically doing 6 times. Okay, hold on. I got to be careful with my numbers here. Yeah, that's what this last picture was on my Krita. Think it's old school RuneScape log time. Probably 36. Yeah, 36. Wow, even my OBS is scuffed. Oh no. I think this is the beginning of the end. Hold up. While we're enjoying ourselves, I'm gonna. Oh wow, it really is the beginning of the end. Yeah, this is gonna have like so many billions of vertices. Okay, I need to close this right now. I just realized I'm gonna break it. That's what I get, guys. That's what I get for using the wrong shader. Oops. Now you can support me by clicking the Thrones link below and getting buying me a brand new graphics card. And by supporting me, I mean, I have no idea. I don't even have that yet, so. If and when. Yeah, I don't happen to have a throne. I was lying about that. Man, look at that. I'm really, like, chunky. Fractals are scary. This is what it entails. I lied. Yeah, I actually don't have any, like, support. You guys cannot buy me anything. I'm, suffer silently, but very vocally. Is that right? In the meantime, tell me what sort of fractal things that you guys have heard of. Fractals are pretty cool. That's kind of why I am the Fractal VTuber. Let's go buy stuff for Lars and Throne. No, just go buy stuff for Lars on Throne? You told me something about Lars and Throne. Does Lars basically have a throne? Once got a hairline fractal on your wrist. You're funny. I heard that this really cool fractal guy. We should save some money and buy him a new graphics card. Okay, let's calm down a bit. Your throne is just stuff for him to sit on. It's just stuff for him. All of it. Nothing for you. No plant stuff. No like special kinds of seeds or breeds or anything like that. Interesting. That's really cool. Here's what I was gonna show. Is that one of my last frames here. I was describing this. So we have an issue with the scalability of some of this stuff. Okay, and that's because it turns out that once we create a new instance of itself, right on the very end of it, then we start adding tons and tons and tons more, like exponentially more. Right? Very inconvenient. I'm suspecting it's big O of NN. Oh, poisson. You're gonna irk me there, bud. Shoot. Okay. Oh, thank you very much for the subs. Poisson, poison invariance. You applied mathematician. It has actual money. That's how cool. Alright, I gotta celebrate. I gotta actually hold on. I have some wine right here. I gotta actually drink some of this stuff. That was gonna be the case for today. I got some Merlot wine. Console, you're here too? Console's one of my friends. We know each other. Console's here too? That's so cool. Yeah. We have an ad also in 3 minutes. That's perfect because wow, we don't actually want to a Murloc. We want a Murloc. I like Murloc wine. Okay. 2 subs for the hype train level 1 or something. What is this? I actually don't know what this is.
6, 7.
Fuck. Okay. Okay, that's great. That's great.
6,
Alright.
7.
I totally forgot I had this. We're doing it. We're doing it. We're doing it. Check. I don't have my glasses right now. Fuck. No! No! Not doing it.
6, 7.
Damn it. Woo! I don't even know what this is all about. You guys are ridiculous. much. So dumb. One of my favorite memes ever. Still think it's trash though. It's the best meme ever. The best meme of 2026. I think it's great. I spent some time on to get more money to give to the map. What am I gonna do? I can't just take money. I don't know. I'm very okay. You know what though? Let me actually tell you a plan that I have. Okay, pretty soon, and the not next few months, but few more after the next few months. Okay, I plan on doing probably a subathon, like a study-thon, because I am gonna have to cram a bunch of things together, and it is gonna be my responsibility to actually study for what's called grad school. So I do want to do that all live, and I feel like my enthusiasm will actually keep up very well with it. It would be really cool for me to cover all the basics, go into some extraneous stuff, and then, yeah, it would just be really cool. I think it'd be really, really, really amazing to like do a subathon to get me to, I don't know, for tests or something like that. That'd be so cool. Grad school. Let's see. Terrified Games, congratulations for your graduation as well, by the way. Poisson, congratulations to getting to your first school of choice. Good job, Nep, for not going back to school, I suppose. Yeah, no, I'm just very excited, but I gotta like apply for everything this year so that I can actually do everything later in the year, which means the next year. So yeah, that'll be cool. Okay, all that to say is that I'm gonna go back to the Fractal thing. Undergraduate supremacy. I was like that until I couldn't find a job. Getting close to it. You should definitely stick with what you know. Yeah, the likes are great. Thank you guys so much. I really don't know what to do with this. I don't know how to monetize myself. So whatever you guys do is just so cool. Okay, so I appreciate it. Ads are snoozed. Okay, good. So all this to say, I happen to have a geometry node. Oh, it didn't save. So I guess I can do this live then. Let me go back to the project real quick. Okay. So if I remember, I've been doing this, rehearsing this one a little bit. So what this is gonna be called the Menge sponge. So all these individual little squares right here. Zoom in a bit. A little too much. What do you notice about the shape of them all? Does it look like there's squares here? A large twist. Maybe this isn't good for those people with trypophobia. Actually, it'd be really funny for people that have trypophobia. Because that's what we're going to do right now. Okay, so here's how this works. Remember I just mentioned that you can catch at each of these points right there? So, 2 points. So I can turn this all into mesh data. Actually, no, even better. Instances. So I can take the geometry I have and give it the point data. Okay. Next, I also want to look at a cube, because the cube is really the shape that I'm going to give it. And then I'm going to turn it into a cube. Okay. Oh, we got a hype chest. You guys will get this right here. That's cool. Tripods are scary. What is it about? Okay. So all the points that I generate from this cube is going to be an instance on the corners now. However, what I also need to consider is the position on these points, okay? So let me make this into a group. A group lets me organize things a lot better. Okay? So on each of these cube points, 1, 2, 3, 4, 5, 6, 7, 6, 7, 8. Okay? Then I go into each of these positions, and I'm going to do a vector. A math vector, okay? If you don't know what vectors are, don't worry about it. We're just going to grab the length of it, okay? How long is this vector? And I need a math greater than. So there's operations. There's math and geometry nodes. Isn't that actually very cool? Greater than. So if a number is bigger than 0.6, then I'm going to draw it. And this is going to go into my selection method. And then my group method is going to go all the way into instance. And I don't want these to get too big. I'll show you what this does in a second. But let's go ahead and get out of this group. And then I don't want to do this anymore. I want to make sure these are cubes. Okay. Plug this in. Wow. What did that actually do? Well, let's go look inside the group again. Okay. Oh. Aw, good night, croissant boy. Look at the shape. Look at the shape. So if I want to get like a matrix of things, then I can grab individual points and I can slice them up. So this number right here tells me how many different things I can hide inside of them. Good night, Poisson. Do the lurk command. Do the lurk command if you're still here. Do the exclamation lurk. It's really cool. It's definitely something you'll understand. Please, 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 please. That's chill night. This is a pretty fun night. Lurk. There you go. Yeah, warriors left as it's left as an exercise for the reader. I think I saw that from another math person streamer. I can't now name their name to like save my life. Very cool. So yeah, I can grab each of these points and I end up like using them for the geometry data. So in our case though, if I'm using 1, it's way too big. So actually I need a scale factor. And if I'm using 3, then I want them to be about a size of a third. Got that? And thanks, console. I know you. I know where you live. Yeah. We're friends. Very cool. So that's how we get stuff like this. Okay? Now at the end here, what I can do is I can keep iterating over and over, and I keep getting these individual shapes. Now the scale factor is off a bit, so let me go back up again. Let me do something like 1.5. That is just big enough for me to use these numbers properly. 1.5. Okay, so now if I re-instance this thing, then they're all gonna have a hole in it. What's really happening is they're making small versions of the larger blocks. So if this small thing has 1 cube, then it tells it which cubes to use, right? Because we have a threshold. This threshold says the ones that are farther in the outside. If I make them a little smaller, then the ones that are a little too big is the slider. So 0.6 is the threshold. Got that. Last thing is you can do this several times and it looks really cool. Okay. And then I found out 3 is about the limit. I'm going to save really quickly. And if my computer chunks, then that's why. Let me see. What time is it right now? 10:55. I'm gonna operate one more chunk real quick. And to show you what's going to happen. So all of them are going to get updated. So all of these. Now, last thing I want to say about this is that the actual density, all of these, the reason why this thing is black is because these are all individual points. All individual vertices. So if I click away, that is quite dense. And if I go over to my statistics real quick. Then I can identify how many polygons and vertices this whole thing has. And in my case, well, I guess I have to update it over here too. Statistics. I have about 6 million vertices right here. Stats. Yeah, no. Stats. So, this is about 6 million vertices that I'm working with for this one object. So that is kind of a lot. That's why my computer is chunking really badly right now. Okay? Pretty neat. Now, you guys are a little quiet. What do you think about this? I will explode one of you guys unless you answer right now. Pretty interesting, eh? Not Canadian, what I'm talking about. Vertices. It should be something. Oh, what could that be? Something really funny. So yeah, 6 million vertices. That's quite a lot from like the last one, which was like 5 logs. That could work. So here's what I'm gonna do. I can actually realize these instances because these are not genuine yet until I click apply. So when I click apply on this particular object, oops, I gotta click it. Come on. Nep has more logs. I believe it. Billions and billions of logs. Please work. Evaluated geometry from modifier does not contain a mesh. How does it not? Unless we're the mesh the whole time. Geometry nodes. Okay, something went wrong then. Okay, so let me eliminate this one because I don't want my computer crash. This over here currently has... That does not look like 26 vertices. What? That doesn't seem right. It's supposed to work. Nep has more logs. Got over 2 E13 logs. I don't know. I gotta play that silly game. I really want to do cookie clicker as like maybe a sub goal reward. That'd be really cool to be like, hey, if we get this many things, we're gonna start playing cookie clicker, and we're gonna keep playing cookie clicker until we get several ascensions. And then maybe a session will just be about like how we actually explain how to read the number. So like instead of saying like 10 million or e to the 13, e to the 14, so you don't have that in cookie clicker. The instance is just the words, which by themselves you can actually just say, because once you understand where they come from, it's just Latin. It's just, you know, it's just duodecillion, duoundecillion, duo 2-cillion, something like that. Pretty cool to actually like pronounce them. Well, I wonder why this is not working correctly. So let's see. I wonder if it's possible to do this too, but instead of this with a cube, I'm gonna do something with a, let's say something much simpler. Let's do a circle. A cylinder? Is there gotta be like a pyramid? Are there pyramids? No. What would this look like? 32 vertices. I'm generating a cylinder on top of every single point on the cylinder. Can the cylinder be harmed? Yes, they can. It seems as though my computer does not like it very much. Oh, I know why. Because our instance object... Oh, this looks like Minecraft. Shoot, never mind. So, the actual shape of the cylinder, by the way, looks like this. So, if I can find all the individual vertices, I can't see it very well, but I'm going to draw it. But like, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all that stuff. Cylinder can be harmed under some specific circumstances. So, when we're out of it, and we just use them as instances for other shapes, we can generate some weird things. Now, where this really comes in handy is for making shapes specifically from the meshes. Okay? So, here's a math function then. Okay? Exactly where this is right now. Be gone. What I can do instead is I can erase this stuff. Then I'm going to generate a math function, which you can do. Thank you very much, Terrified Games and Terrified Games /TV/Terrified TV Games. Thank you. I should specify I'm not actually hydrating. I'm drinking wine. I'm on a roll. But one of the cool things you can do in Blender is actually draw a function. So give me a 2D function. 2D. Guys, a 2D function. I'm going to pull up Desmos so you guys understand. Wine would be nice. It would very much be. Terrified Games, did you not get a... Are you not a sub? I have one free gift sub. I'm willing to give it to someone. I don't think I ever got it. I lied. Nah, it's all good. You shall suffer silently then. Observe. Give me a function. X. Y equals what? Y equals what? Y equals x squared. Y equals mx plus b. Tyler, I will not use that. X squared is pretty good. But I don't want to. It's really hard to use it. Cammy, hi. Hi. Everyone say hi to Cammy. Cammy, guys. Hello. How are you doing? I've seen you. What is up? So, I'm going to be doing a math function. Z math surface. So, if I do y equals x squared. Whoopsies, this is also in Python, so I gotta use star. Okay, so this looks like a pretty big thing. I'm gonna make it a lot wider too. And I really don't need all this space data. Okay, so what I can do instead is I'm only gonna grab a sliver of these points because they are all matching the same function. And I'm gonna separate this. So I'm not using this anymore. I'm gonna grab these points. And just to prove a point, I'm also... No, I'm not going to change it anymore. So the geometry nodes that I just used right now, which says I'm going to draw a shape on every single instance of this thing. That's what I'm going to use this. Oops. So not with the shape anymore. Instead, what I'm going to do is I'm going to do group input. Ooh, interesting, right? So that is going to be my input data. Or I guess that's going to be the shape that I'm going to draw on every single instance. That's not what I want. So instead what I want is I'm going to draw a shape into the point selection. And I'm going to draw a... I'm going to do a cube. And I don't have a threshold. I don't need a threshold right now. Whoa, look at that, guys. Does that look like something you've seen before? And I could keep drawing infinitely many if I wanted to. So where's the use for this? Because each of these are individually drawn shapes. So let's say you don't even want a cube for this. Let's say another primitive, which is what they're called. Let's say I want stars. What? Now let's say I don't even want this to be the thing, but I'm going to go back and use this original function for the thing. Okay? So all of these points will get drawn. I'm going to actually spread this out. Oh my goodness. Did I break it? I should really draw a different blender thing for this. It exploded, so I'm gonna use explode. Hey, you have exploded. You're still here? You went quiet. You went moot. Come on. How come you're not talking? How come? Did I get inflated? Okay, never mind. Go back to... Cease your speak. alephmuvt. alephmuvt. That's a good one. So let me use this again. I'm gonna use this instance of geometry nodes. And then I draw a point of this thing on every single surface. Does that make sense? Does that seem like it makes sense? Let me know if it does not make sense. 𝖘𝖔𝖈 has exploded. That's good. 𝖘𝖔𝖈, how does it feel to have exploded? Makes sense to me. Okay, so here's where we can use this to our advantage for other wacky and very cool things, okay? I will just create a new scene for this so that I don't break everything. And I will have to remake the geometry nodes. Okay? Oh, I could just reuse it. Thank goodness. That doesn't happen. Okay. So, my robot has exploded. So, we can change the actual shape that we want to use, okay? But if we have infinitely many shapes, I can draw differently way more. Or, let me go back in here, and I'm going to change them to something simple like balls. Actually, spheres, what do they call it? I'm going to do a icosphere with one subdivision, because it's actually fairly simple. I believe this is referred to as a D12, or let's count the sides. 5, 5. Now this is D20. What am I saying? Okay, for all you D&D buffs, why is my world so dark? Oh, and these don't even have a shader on it too. Yeah, that's good enough anyway. But you see that we can use this to our advantage to create some wacky shapes. So now, what if I did, like, let's say some stairs or something? Not just any stairs, okay? But let's say I have a staircase. Might be a stupid question, but is this a source to learn these shapes like D12 and their properties? Is there a source to learn about the shapes? Yeah. So that is those are our polyhedron models. I actually have a whole book about this. Hold on. Now, they are referred to as regular solids. Actually, some of these are regular solids. Icosahedron are also regular solids. So they are, in fact, a very, very well-studied object. I have a book full of really old type of shapes. And they also give me, like, the radius from the center and stuff. So, oops, you can't, that looked weird. I'm looking down at my book. So, they gives me, like, a printout of the shape and how to fold them up. And there's some really, really wacky 3D shapes that you can find. So let's take, for instance, I'm sure there's a site for this. Let me look it up. Let's take, for instance, regular or polyhedron models. Hedron models. You aren't seeing this right now, I know. Animated polyhedrons. Math is fun. Yes. Okay, we're gonna do this real quick. Give me a VTuber with nothing. None? Okay. So, you can find all sorts of wacky, different shapes right here. Yeah, there's no such thing as a stupid question unless it's the one that I ask. There's such thing as a stupid question unless it's the one I ask. Yeah, Tyler. So, let's take a look at some. Everyone knows what a tetrahedron is. In the Dungeons and the Dragoning, what is this called? If you guys can see this very well. Let's change the coloring method from this to shaded. Multi. It's a four-sided die, right? So this is a tetrahedron. I can also draw this and show you. It looks like this. And I do happen to have a bunch of regular solids as well. I believe it's in the math functions. Regular solid, yes. So I have hexagons, octagons, dodecahedrons, icosahedrons. And wow, look at that. That looks very funny, doesn't it? Now, all the terms that you use for this are also called truncations. So edge truncation means what I would refer to as beveling. But every single... This creates a new face. So now, what does this look like to people that play the game and use their feet to play it? Whoa. You know? Let me draw an instance of this right now. There's usually a field, and then they grab this thing, and then they usually use their legs to play with it. Yeah, okay, there's one of those then, huh? So then what I have here is I'm gonna have a it's just cheap enough for me to do a mesh. So I'm gonna go right here, and then here. Actually, I know what I need. I need a force. Use the force. I'm only saying that once, by the way. I don't like May 4th. Personal reasons. Whatever that means. That's not what I want. I'm going to do a wind force. I just realized the forces are too strong. That's a ball. Did you learn anything from that? Did anybody learn anything from that? Yeah, we did some stuff. I'll hydrate. I'm gonna drink some stuff. You learned it's ball shaped. That's right. Back to our website. Okay? Let's check out some other wacky terms right here. How about we look at the great 𝖈𝖗𝖊𝖎𝖎𝖙𝖘? Let's take a look at this. Oh, this is a 𝖈𝖗𝖊𝖎𝖎𝖙? Everyone knows this. Wow. This looks very similar to something we have already seen before. Spin it. Explode it. And then we can see the net. This is usually called the UV map. But in our case, this is just the net. So if you guys printed this out, you can fold this up and then make it. In my book of polyhedron models, we get some really wacky names for things. Let me look up one that is actually absurd. How about the 𝖈𝖗𝖊𝖎𝖎𝖎𝖙𝖘? How about that? Let me look it up on the side real quick. The 𝖈𝖗𝖊𝖎𝖎𝖎𝖙𝑘. Everyone knows their basic regular solid shapes. Wow. Say check for spelling. I did. Oh, rhombo. There we go. We got a polytrope. Yeah. Everyone knows these shapes, right? You guys can fold this up too with paper. And I'm not even lying about this. It's possible. This is done in the... Actually, wait, hold on a second. It looks so convincingly like paper, but I think they had graphics at the time, huh? What is this made in? This book was made in the 70s. They had computer technology then, didn't they? Sure. Anyways, I'm gonna upload a bunch of UVs. So if you guys end up printing them out and then folding them up, that'd be actually really cool. You can share that with me if you want to spend the time for that. I happen to be a little busy. Actually, maybe I can make that a reward goal. What? Oh yeah, and look at this. There's a circumradius. The circumradius is about √5 minus 2 √2, all divided by 2, which is about 0.7 or so. The volume is about this much. The dihedral angles, all these wacky terms and stuff like that can be found. Isn't that interesting, Kami? Cammy? Isn't this cool? And then I'm gonna call an explosion command. Karmamos, I apologize. Interesting. Interesting. So yeah, there's tons of things you can learn. Sugaroni has exploded. Ripperinos. Ooh, there's a ton of these. Hold on, wait, hold on. Let's look up the 𝖈𝖗𝖊𝖎𝖎𝖎𝖙𝑘. Quasi. Oh, we don't have that. 𝖈𝖗𝖊𝖎𝖎𝖎𝖎𝖎𝖎𝖎𝑘. This is the great one. So there's 3 of them. The 𝖈𝖗𝖊𝖎𝖚𝖃 or the great 𝖘𝖔𝖈𝖎𝖆𝖍𝑒𝑡𝑡𝑡. That's this one already. The 𝖈𝖗𝖊𝖎𝖚𝑃 is this one. And then let's look at an augmented triangular prism. Wait a second. This looks a lot suspiciously like a... It looks like a spaceship. So much to learn, man. Without academic pressure, it feels liberating when you study. This is chill. Like we're just learning things as we go. Honestly, I don't know everything, and I was gonna go for one thing. And yeah, this is a vibe. I'm not here to give you guys math homework. I'm here to talk about this stuff and be like, this is cool, and just go down rabbit holes and stuff, and parse it as best as I can. Pretty cool stuff. Okay, I'm eliminating this. This is gone. This is gone. Go back here. So I wanted to do a staircase real quick, okay? So, if you've ever seen a staircase before, they usually look like stairs, right? So here's a way I can add stairs to this. I can bevel this side right here, but I get this really cool thing called a profile, okay? So depending on the profile that I draw, in the segments, I suppose, it will match that profile. If I go back over here, this looks like something I can keep instead. Now, if you have a house, or you live in a home, or any sort of like living space whatsoever, then you probably have seen something like this before, where you have support loops. No. These, what are these called? Cornices? Cornice moldings. Where these are basically the seams on the bottom of the walls and stuff, right? So that, you know, you don't end up hurting yourself on the things. A crown molding, is that the case? Is that more accurate? Crown molding. This one's a little different. But I can create any profile if I wanted to, right? So I do a default real quick, and then I believe I can move it all around then, huh? And then, of course, I can adjust the pressure. And it's going to follow this exact profile right here. Looks like a mouth. Hold on. Any Corona fans out there? Any Corona fans? Hold on. If you guys don't know what I'm talking about, this is great. Corona, the VTuber, that's what she makes her chat look like all the time. Ah! References. God, this is so fun. Anyone get this now? Yes, no, yes, no, yes, yes. It's gonna be on the quiz later. Okay. I think it looks great. Yeah, yeah. I am a VTuber fan by heart. Okay, anyways, all this to say you can use the segments and stuff like that to do cool things. Okay? So yeah, we're gonna start with some steps right here, okay? Something with scritches right now? What do you do? real quick. Does these look like stairs? So this little segment right here. It's all about the scritches right now. How are you still here? Thank you so much. Yep. For hanging out, yo. We vibe. So there is a modifier called the screw modifier. Okay. Which means I can. Who remembers from calculus that you can go and revolve around an object? Remember when you learned a revolve around objects and stuff? Well, you can do that here. So if I look at this profile right here, it looks good, but I end up revolving this pi many times, right? Pi is the angle. So if I reduce the angle, I can stop revolving it. Round, 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 round. Right? Pretty interesting stuff. Yes, there's pi stuff. And then we can even do several iterations. So I can tell it how much I can actually raise this by. And what does this look like now? What kind of shape does this look like? A swirl. Ton of power. A ribbon? I suppose so. So there's tons of things you can use these things for. They don't have to be math based. But I guess that originally they start out some way. So basically what I'm doing is I'm creating a profile and then I'm revolving it. So if I take this right here and I bevel this. Sure, we'll do that. Okay. Screw it. Hey, that looks like something convenient for like CAD modeling or something. So why don't I like just straight up create different shapes right here? Oh yeah, this is still only just 1 point. Create a cursor, scale it by x 0. Right? Oh no, I have some shape in here I don't want. No worries, I can just leave an opening like that. And oh no, these both are not the same thing that I want. Well, no worries, I could scale it by x. Wow, I made my 3D model the thing really fastly. Isn't that kind of like epic cool? So yes, we can make precision modeling. All we need to do is keep track of the actual numbers right here. And it can come out pretty fast and pretty quick. The turnover is not too bad. Epic. Pretty cool stuff. Bam, got an object. Alright, this needs to go to the 3D printer. We're gonna go and do this, and then we're gonna do everything we want with it. Pretty cool. So yeah, tons of things you can do, and then if I need to like screw it, then it can go up and down, and I can tell it how many times I want it to do it. Isn't this actually cool? Isn't this like amazing? By the way, I learned all this on my own, like completely on my own. I wanted to start with this to say that I can create a math object. Let's say I want to create a math surface, okay? So there's several presets, especially this thing right here. This is pretty interesting. This is very practical. Everyone has this in their backyard, right? What is this called? It's a shell, right? So usually snails have them. but not just snails. It's a snail shell, but not just snails. They're in your backyard. They're in your walls, man. They're in your walls, man. Don't you know? They're in your walls. They're right there. Don't you know? They're right there. They're gonna pop out in there tonight. A nautilus. A nautilus. That is correct. So, yes, everyone has these in their backyards, and that's actually really cool. And you can specify the number of objects it can be, or number of helper functions and stuff. Okay? Really cool stuff. Now, why is it still popping up? What's the deal here? So I can specify all the stuff if I wanted to. There's different sorts of functions as well, and different spirals too I can use. And I didn't even cover like shapes right now, but like spirals are really cool. So there's several different kinds of spirals I can use to draw a shape. So I think the simplest I'm going to do right now, just to prove a point, is the Archimedean spiral. Which, where am I at? I'm adding a curve. Curve, spiral, Archimedean. So Archimedean spirals are super cool because they actually are a constant growth radius, which means they can do stuff like that. Constant growth. Okay? So if I want to use these points for, let's say, the shader right here, then I just end up using this. Who's ever watched Uzumaki? Or, excuse me, read? Definitely not watched. I'm gonna give this a material too. Rendering shader. Work. I'm gonna head to bed for the night. Thanks for the stream. Oh, of course. Thank you guys for coming in, I guess. I'm kind of just vibing right now. I'm really just, I realized I'm not really covering too big of a topic, but I was covering with shaders. Basically anything that I wanted to. I'm just very happy to like explore and play around with these things. It's so fun. Yeah, bye Oni, Sugar Oni. Have a good night. Got your sub now, I guess. Crazy. So yeah, I can use any sort of like set of points I can make to make it generate other shapes. Now, if I spent more time on stuff, what can I make this for videos? What kind of videos can I make with this? It doesn't have to just be fractal stuff. It can just be like anything. So this here is a logarithmic spiral. This looks like something I can use for like space stuff. And logarithmic is actually pretty good because I could be like, look, it's the exact same thing if I zoom in a bit farther and a bit farther. So maybe this could be used for... Look at that. Oh, what if I made the distance increase? Make a tornado with it, space stuff. Yeah, right? I kind of want it to be like... Wait a second. Seed packing. Nepenthes, you're back. Seeds. Fibonacci. Phyllotaxis. Doesn't this look familiar? File taxes? No. It's 4 in the morning when you streamed in my time. I couldn't join you. Cammy, where are you at? Europe? Why Europe and Europe? His music's got me too jumpy. Aggie made it. Oh yeah, you just streamed today, right? Oh shoot. When was that? Shoot. I was working at the time, I'm sorry. I'm also changing the music. 4 p.m. for me. Yeah, I was definitely working at the time. I was teaching my students about fractals. I'm changing music, by the way. You can't stop me. I'm doing Pokemon. Okay. Another sub goal, I guess. Play a Pokemon stream. But this time I have to calculate a bunch of nonsense in advance to actually do stuff. So it'd be really cool if I can do a hack. But like basically overanalyze everything. Like on a technical level. I suppose things that matter. I don't want to run every single RNG because it is a Pokemon game. So it'd have to be something simple. Or it'd have to be something a lot more manageable. Am I making sense? Sounds remotely rude. Don't disclose nationality, ethnic stuff due to racist. Oh, okay. Yeah, no problem. You're chilling. Hold up. No, yeah, fine. It's the internet. Stop. Yeah, you're chilling. Yeah. So no, it's just a different time, so that's fine. But yeah, sub goal would be for it'd be for a Pokemon thing. I'd really want to do that. That'd be really cool. Now it had to be a specific generation that I don't want to like. I don't think it'd be the worst to like calculate stuff for. Yeah, no problem. You're chilling. Look, honorary Canadian. All right, you're Canadian now. Is that okay? Is that okay? I don't know. Neb, you said that, so that's your responsibility. Let's see. Canadian online is okay, cool. So yeah, this one looks like it's a constant rate. It's not the best, but this one has a logarithmic rate, which is why they spirals like this. There were several of them. Pretty cool. What's another one? A spheric. Oh, these are cool. So these are polar coordinates. I'm gonna do one. Okay, so if I start this correctly, what I can do is I can grab an object. Ooh, look at that. Ooh, look at that. What could I possibly do with this? Oh, I know. Grab this shape. Do a coordinate thing real quick. But these shapes right here, they have to be really small. So I'm going to make them small radii. That looks cool. You're also going to bed too? No problem, Nep. Ah! Oh, this is actually incredibly handy too for like making things start from the center and then bursting out. That's a cool effect. I guess that's how they would do it. The stars aligned. You'll go lie down, you'll be here longer. Okay. Yeah, let me, it is getting pretty late. I am just kind of like messing around. Surprised you guys are willing to listen to all this. Pretty cool. So that's this kind of spiral. And then the last kind of spiral I can just use by default. I like me a cute, oh, okay. Why wouldn't we listen to you? I don't know. I feel like I'm just covering like basic stuff, but I guess not. Oh, knots are cool. Braided knots. Oh, this looks fun. Oh, let me show you how I can make something for this. Okay. I want to create a braid. Tyler gets it. Yeah, okay. Let me show you something cool. So this here is the shape. This is the braided knots. I could also create something with it, or hear me out. I can also create a thickness. Skin. What I can do is I can make this a mesh shape and give it a skin modifier. And bam, I already have a bracelet. Tyler exploded. Nice. He exploded himself? Is that what happened? Nice. Hold on. Let me try myself too. I exploded twice last night. It was so good. Oh, that's good. Nice. 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 It did that. Anyways, you guys like the bracelet? Huh? Wait, what are you referring to? Get out of here. Anyways, isn't this kind of cool? All the data I get on the side right here is also like pretty interesting stuff. Oh, look at that. Well, it works, so it's not gonna break. That's nice. There's tons of so many cool things I can do. So hear me out. For game asset design stuff like this is actually really easy to do, but I just have no game to do it for. Unless I can do it for a potential game stream. 3D game stream. in the future. A video game in 3D. It's a game. That would probably be pretty cool. I've been wanting to make a game for some time, so I think I have the skills to do it. Plays less games than... yeah. What games have I actually played recently? They're all just like puzzle games or... Actually, I do have another one I have in mind pretty soon. It's so fun. Okay. Like I did. It was, like I said, Tyler, you're here for that. I want to do Dad Simulator game. Or I guess Mahjong. Mahjong was great. Mahjong was fantastic. League of Legends. Yeah, I mentioned League many times. Do I want to play League of Legends? My favorite game. I'm a real epic gamer if I play League of Legends. I think so. But it is a dad simulator game. Or more like a daughter sim game. Never played League? Don't worry, I won't be having fun playing it either. Hold on, can I possibly play that right now? Sims? I think the time to roleplay is a little too much. Maybe for like... Gotta get on old school RuneScape. You're funny. You're so funny. Hashire, Uma Musame. I don't know anything about Uma. All I know is that the pink one is the dumb one. I know that the one that's a ship made of gold is also a dumb one, and somehow like has aura for some reason. There's one with the lab coat, and that one is apparently pretty amazing. She's not dumb. hold on. I got one. Explode. Yeah. Maybe I should announce that in Lake Tech and be like huge dead. Yep. Hashire, Uma Musame. A lot of accidental casualties with your explode. It's fine. That's the whole point of randomness, okay? Not fate deciding it. But I guess it literally is. So be it. What's wrong with that? Man, I wish I streamed at an earlier time. How much longer do I have? My bot has exploded several times, in fact. What are the odds of that? 1 in 100? It's not random. Watch this. Okay, hold on. It's been my friend, stream elements, and then my friend again. Give it one more roll, and then we won't say it's random anymore. That's actually crazy. Those are actually, like, crazy odds. Where the hell's Penbu gonna show up? I swear, I gotta show him his freaking... I spent so much time on Penbus, okay? Look at this. Look at how cool this is. Look at how cool that is. It's Tetris and then music. And it's got a little T-spin on it. Because he does that stuff. Don't you know? I know more about him than you. The viewing audience. I thought it'd be really cool. Knots. What's another one? Celtic knot? I just did that. Go to his streams more? Well, he's pretty interesting, but he's like doing so much, and I'm like, I don't get it. Wait, why are we starting here? Apparently that works still. Yeah. Okay, if that works, I need to actually make things like cost appropriate stuff. Okay, so I'm gonna give this a skin modifier. convert to alephmuvt. I get it. Mewing. Is that dead yet? You should get on Animal Crossing. You should. Animal Crossing, I have that, and it's really fun. Especially with friends. I didn't have friends, but it's especially fun supposedly with friends. Supposedly. Nep, is it fun with friends or no? Remember, I got it when it came out during COVID time. It's supposed to be fun. You said you don't have Nintendo Switch Online. And also, I've been busy. Like, not even anyone's fault. Whoa, this wine is kicking in all of a sudden really good. What the hell? Whoa, I'm feeling top notch. Wow, that feels nice. I feel very vulnerable right now. Okay, imagining copper wires looking at that. Let's look at copper wires then, okay? Oops, that's not the right one. Okay, let's look at this. And we're going to add... There's several ways I can do this. I can actually do it the hard way. Yeah, this looks about right. My only issue is that that's not quite the tone I'm going for. That's why Tyler and I are BFFs on Animal Crossing. Just didn't have the Wi-Fi for 24 hours. This looks like wires, right? This looks pretty legit. And the best part too is that this doesn't actually have to be... Oh yeah, the profile, huh? Look at that. So I can just start from corner to corner and just keep drawing the wires I want. Better part is that I can animate this. Okay, let's say this right here is a certain kind of like coil, right? And the experiment is to wrap the coils around it. Okay, so we understand that the magnetic coils induce when you put a current through them. So all the way back here is where you induce a current. And to emphasize this a little better, I think I'm going to have this as a little thicker wire, okay? So a way we can demonstrate this is that this right here is the coil. And it is actually going to be wrapping around this ring right here. Okay? So there is actually a way to calculate how many rings produces a magnetic field. which is actually really cool. So, but it can be done very much something like this. Okay. Electricity math, you're out. In, out, yeah. No, come back. So, hold on, pay attention though. Because, like, depending on the gauge of the wire and the gauge of the radius of your coil, then you can get a bigger or smaller magnetic field from it. Which is really good because that's how, like, transformers work. That's how microwaves work. You didn't say please, Aleph. Hold on. What do you mean? What are you talking about? Hold on, look at the thing. The transformers, right? Yeah, no, yeah, robots in the sky. Come on, pay attention. No, look at the thing. Look at the thing. Look at the thing. This is coils. Okay, coils. This is very important. You know? And sometimes you wrap it around enough times. You wrap it around enough times that it ends up basically covering it several times, which is really good. And then this is where the electricity is going to spark from, okay? So hitting level 90 right now, 59. It's ads. Take a look. We are learning about magnetic coils right now, okay? Do you remember anything about magnetic coils or no, by chance? Because here's what we got so far. What we have right now is that we have a copper wire, and the copper wire wants to wrap around this coil, okay? And we know from, I don't want to say Gauss's law. No, it's one of the magnetic field stuff that the number of wires produced, depending on the gauge, of course, and the number of spins, you can calculate how much magnetic force it has, right? This is just a small little factoid that we're remembering right now, but I want you to observe something like this, okay? So when you put the wire through, you can wrap it around it, okay? Wrap it around it. So you get something that fits like this, okay? Gauge measurements are stupid, though. What do you mean? The smaller number, the bigger the thing. That clearly makes a lot of sense. Clearly. Anyways, if I do this enough times, then electricity would produce a magnetic field. I'm surprised no one's clipped this yet. You're doing interesting stuff for science right now. What do you mean? Yeah, no, you put the gauge in right there, and then you put the coil through just a little bit, and then you wrap around the coil, you know? And then it produces a magnetic field. It's so cool. And that's how you can make things produce energy, electricity. In fact, if you move the coil a bit, then it also produces a magnetic field, which gives you energy, right? Sometimes you got to be a little... The faster you go, the better. But the slower that you go, the less energy that you have. Because there is resistance coming on. You put your put in the put. You put in the put. Put your put in the put, and you put it all you put, and that's what it's all about. Okay. Sometimes you can wrap it around like that. Freaking, hold on. Okay. I love plant girls. They're so cute. They leave. The leaves and pictures are so cute. I want to water them in IRL. They're so cute. And the pictures and leaves are so cute. I love plant girls. And Also, my BPM increases by 5 when I see a plant girl pick because they're so cute. And I would love to water the plant girl's roots. I would do it 24/7. I got mad right now because I realized there isn't 18 billion drawings of plant girls. They're so cute. Plant girls are so cute. Nobody realizes it, and I want to water a plant girl. Uh-huh. Anyways, that's what you can do with the coil. Let me show you another project that I've done once upon a time. Kolak is a genius. Brilliant. Let me show you a project I've done once before. And I'm really disappointed that this one didn't work out very well. I was doing a project once upon a time. Or I was doing a 3D tutorial about these things. And so I made all of these things from scratch. So they had little cutouts and everything. And I had a bunch of little nubs and batteries and things. And I measured all of these for my hand. These are modeled by myself. I'm gonna let it sit for a second when I am done playing with it for a sec. Yeah, not just any battery, AA batteries. That's definitely what they're called. I have shafts. I have a little metal gauge right here. Like, I need to emphasize, these are still, in fact, 3D models. Right? So I look over here real quick. All of these are 2D. I'm sorry, 3D. I made them myself. I modeled them myself. So I can call this one... This is supposed to be... A1, A1, A1. Yep. These are supposed to be kind of batteries right there, but they're not. But we were going to do an experiment, and the children were going to learn how to actually use it. But no... I didn't get permission from my boss to actually do a video, even though I gave them the proof of concept and I had the skills to do it. And I could do it in-house at my cheap rate of hours per minute, of hours per dollar. That one. This piece was especially cool. That one was pretty cool. Actually, this one, I'm not gonna lie, is actually really pretty neat how I did it. Because it actually does have like a screw bit at the end of it, right? And it's all one model, flush. So, have you guys used something like this before? Like a screw hook thing, Majigger? Whatchamacallit? Yeah. So like actually modeling it was actually really cool. Basically 2 halves, but it was really cool. And then the tool itself was actually so cool to do too. I know it's a bunch of like I think this one I cheaped out on the Phillips head, but screw eyes. It's an eyelet hook. What was so cool about this frame was that like I was showing that like, oh, you can animate the things here. Did you know that? You can just animate them back from the table. Maybe that's like interactive video game stuff. And then hold on, look at especially this part. Look at this. Look how legit this looks. That's an emote. Will this work? No. Maybe there's a way to do it. Oh, my favorite part too was the LED actually does have a light in it. Ah, hydrate. Okay. Thank you. I only got wine. Wine for days. Oh my goodness. Anyways, if I ever made this tutorial, it would have been the most amazing thing ever. It was basically a wire clearance activity. So you know, like what I was just doing with the wires and the silly ring right there? It's gonna be one of those things. Okay, I need more wine. Yep, I'll catch up. Actually, wait, hold up. Last thing I want to show, real quick, because you guys aren't asking me questions, but I want to share stuff anyway. We're gonna go for it's on a thumb drive on my keys because I used it mobilely. Well, this one is cool enough too. I'm gonna show you this one too. Hydrate sip of water, not wine. Isn't there water in wine though? It's my favorite color. Green. I'm gonna let this load real quick. I'm gonna come back with my thumb drive. Give me a second. I'm gonna show you something really cool. Huh? It's my favorite position of sleep. What? Sideways, usually hugging a pillow? What do you mean? Halo Master Chief Death Pose. To Google. Haha. Yeah, okay. Give me just a sec. I gotta plug this thing in. Okay. Ahead. Okay. I believe I'm able to load this up. But what I really like about this one is I believe material-wise, this was a really cool scene. Oh, I know what happened. Yeah. So back down here, you can actually navigate the cityscape. This is for a video game I was working on with a friend. So yeah. There's a way to do like the view thing. But this was a city that I did once with a friend. Okay. Two trains are driving toward each other. The first train A leaves town A at 5 a.m. traveling at 60 miles per hour. Second train leaves town B at 7 a.m. at 70 miles per hour. The distance between A and B is 455 miles. What did I say, kilometers? What is the exact time that the collision will occur? It's a related rates question. So, you want to do that real quick? You fool. If you want to actually know that question, you're not prepared for me. Observe. So the question states, you have a train Okay? A, traveling at 60 mph. Then we have train B. I'm going to do train B in a different color. One of the most common colors, we're going to do burgundy. Okay? Then we have train B. 𝖘𝖔𝖈𝖎𝖆𝖕𝖎𝖙𝖘. And then that is going towards this one at 70 miles per hour. Okay. I'm not going to read this at all. I'm going to interpret this as a graph. Okay? Okay? So you said the first one leaves at 5 a.m. Okay? 5 a.m. Excuse me. So these are the intercepts. Okay? So if the first one, we're going to say starts right here. 5 a.m. starts right here. So over here, they're starting out at 0. But they're going to be going towards the other train. The other train is going to start going upwards. Okay. So it is going at a rate of 60 miles per hour. So every one tick is going to be 60 miles. Now, why am I doing it this way? Because it is better in my head to just know how far apart they were. In the very beginning, they were what? 455? So this is 455 right here. mph. Don't hit me with a math problem. I'm actually going to solve it. So that's why it is headed towards train B. So over here, it's going to be reduced to now 395. Okay? Okay, now 2 hours later, right? Because it is, you said that. Can I leave real quick? Hello? You can scroll up. Yeah, 2 hours later, it starts traveling at 70 miles per hour, like let's say instantly, okay? So 2 hours later, it's going to be going this way. This is train B. It's going to be going up at 70 miles per hour. So what kind of equations do we actually have right now? Um, 10 equals 0. Are you doing the thing with the binary thing? The thing? Which, by the way, Gen 4 is the best generation ever. The thing that does the thing, yes. Okay, all this to describe two equations, okay? So in the very beginning, we have 455 is equal to negative 60 x plus, oopsies, that's y. Y is equal to negative 60 x plus 455. Now the other one I really don't know because it is a strange setup for the question. So we would have to backtrack where its y-intercept starts at 0 at 2 steps in. So in other words, is equal to question mark, no, 70 times 2 plus b is equal to some 0 right here. Which means that b is equal to 140 negative. Okay, which means our last equation is going to be y Let me use the other color. Why am I doing this? And then since they're meeting at the same point, then you set them equal to each other. I never got to play Gen 5. That's the thing. Ask you questions? I suppose I could. Okay, so we have a system of equations, blah, blah, blah. Let's solve it. Okay, so we set y equal to y, which is 70x minus 4. $140 is equal to minus 60x plus 455. So now we're going to add 60x, add 140, and then we're going to get... Am I getting better at this writing stuff? This actually like is a really neat thing. This is actually not normal. 031x is equal to 595x. Nothing. So you divide that by 130, divide that by 130, and you can identify what time, how much time has went forward. This is going to tell you how much time went forward. So x is equal to some number of time later, 595 over 130. I'm not going to use my abacus right now. 595 divided by 130. About 4 hours and 50, about half an hour. So just about 4 hours and hours later. Or after 5 p.m. or 5 a.m. So it's going to be 5 a.m. plus that 4 hours and a half. Right? Which gets us about... 9, and then I'm gonna do 58 times 60. It's not right. Every 1 hour is gonna be 60 minutes. No. What's the conversion here? Hold on. 0.58 of an hour is gonna get me what? I'm blanking right now. Hold on. 0.58 hours is equal to 1 hour every 60 minutes. Which means I'm going to get that much. Which means I'm going to get 9 times 0.58 times 60. That makes more sense. 0.58 times 60. It's about 34 minutes. And there we go. So they're going to collide just shy of when it turns 9:35. So if you see this on your stopwatch, you better hope it's not the last second. I'm sorry. Did you expect me not to get it? I don't know what you're expecting here. Skibbity Riz Ohio, 6767. Crank 90s, Fortnite Blevins. Am I right, gamers? Am I enough Sigma to like emphasize this math maxing? Yeah, going to bed. I think I should too. I'm pretty tired. This is pretty fun. This has been a pretty nice night. Cute tonight is revoked? What? Wait, no, I'm not that. Not that I really wanted it, but I'm just asking why. Wait, please. I want it. I want to be called it. What is it? What do you call a horticulturist name calling a mathematician? What? Tell the joke. I forgot I have emotes. I can be angry. Tell us the joke. Tell us joke now. I'm gonna be angry. Tell us. What is the joke? What's the joke? Cammy. I can make this an actual problem. I realized I can make this an actual like problem we can like animate and do for her. Tyler has exploded. It seems like some sort of like strange game of hot potato, except hot potato? Hold on. Engagement? Question mark? Question mark? Question mark? Sorry. Okay, let me... I actually do feel pretty tired too, so I am on the same wavelength with that. Yeah, exactly. Hot potato... Isn't that exactly what hot potato is? Oh. Nerds don't have a good punchline, that's the joke. Brilliant. Did you know me and my friend... Okay, so let's go ahead. I feel like I'm gonna finish the night tonight. So let's go ahead and wrap it up by let's go rate someone. Let's see. Friend Susanna Amano came by. She is someone's streaming. Let's go ahead. Let's stream someone right now. Potato is Pomato is online. So of the people that I have right now, I have way too many different ones. Okay, we have Susanna Saikin, which I met the other day through Mahjong of all places. Pomato, was it this? Groovy Moves. Cleo. I could do Leaflet, but she's no. Sind is a co-working streamer. She's from Australia, down under. So if you guys want to Octocat TV, Cammy, are you streaming right now? That's the question. I don't even know because I'm asking for someone to rate. So you're saying Otacat? Okay, Otacat sounds like a name. I trust Nep's picks. I've been incredibly disappointed when asking about, oh, who should I raid? Oh, this person joins, and this person doesn't do anything or acknowledge me. I'm like, well, that's kind of Major Bumsville. That's not good vibes at all. It's pretty embarrassing. So I'm like, wow. I also don't want to bring it up like in bad taste, but I found it really funny. If you guys look back at the Z VOD with me, she asked me specifically before we raided. She said that, hey Aleph, is there someone you want to raid right now? And then before I even got the chance to answer, she's like, oh, no, we have to raid John Wolfram himself. And I was like, who is that? I'm like, apparently it's the dude who actually made Wolfram Alpha, like the coding language for like MATLAB and stuff like that. And I was like, that sounds cool. So I was like, I really didn't have a say in the opinion. I was just like, yeah, what? I'm doing it. People get distracted. No, she had like a lot of energy, so I was like, all I said was like, she's like, should we do that, Aleph? Should we do that? You know, before even asking me first, I was like, the illusion of free choice. Sure. Free will. Yeah. So we're gonna go ahead and raid Otacat. I hope Otacat's cool. Pulled up their stream right now. Who is a kitty cat? Do like kitty cats. Yeah, it happens. You get distracted. I totally get it though. It's just really funny how the sequence went down. Okay, it's taking me forever to actually like load up the. This is the back end that you guys don't get to experience. Which is fine. You're gonna go ahead and raid someone, and that's gonna be 𝖘𝖘𝖊𝖉𝖎𝖙𝖘. Oh, he's very enthusiastic. Yeah, I need a better microphone, I think, for me to be able to be that loud in different living circumstances. But it's all good. Oh, Nep, you were already there. That's crazy. Well, that's really... Oh, yeah, the raid message. Hold on. I have a raid message, actually. Did you do your math homework? But if you're a sub, then you can also do raid message sub, which is going to be with my eye emote. That's kind of fun. So go ahead and get ready to use that. I'm going to go ahead and start the raid. You guys get ready for that. And yeah, okay, let's get this raid. Let's finish the night. I'll, chill. Okay. High energy, guys. Let's do this, okay? Bye-bye. This is going to be me wrapping up the night. So goodbye-bye. I'll see you guys over there. Bye-bye. 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 Let's go raid the cat.